Every interaction with water in its environment is governed by a fundamental force.
This force is not gravity or friction. It is a visible, cohesive force on the surface.
This specific phenomenon is called surface tension, a critical property of water that influences everything from biological processes to global climate patterns.
So how does surface tension work? At the molecular level, water molecules are tightly attracted to one another through strong hydrogen bonds. Within the liquid, each molecule is pulled evenly from all sides, but at the surface, there's no pull from above, only from the side and below. This imbalance creates a cohesive force that pulls surface molecules inwards, shrinking the surface area and forming a kind of invisible layer that holds the water together. This is why water holds its shape and resists breaking apart. But what happens when you heat it up? As water gets warmer, the molecules gain kinetic energy and starts moving faster. This increased motion disrupts the hydrogen bonds that normally hold them tightly together. With those bonds weakened, the cohesive force, or surface tension, at the surface diminishes, ultimately resulting in a lower surface tension. That's why warmer water spreads more easily and forms looser droplets compared to cold water. To show this, we designed a simple experiment. We have 3 beakers of water. One is heated, one is room temperature, and the other is chilled with ice. Using a glass pipette, we carefully dripped water from each beaker onto the round surfaces of small counters. We recorded the number of drops it takes for the water bubbles to break. The number of drops is inversely proportional to the surface tension. More drops means the water molecules are holding together more effectively, showing a stronger surface tension. Our results were clear. Colder water held the most drops, followed by room temperature water, with warm water holding the fewest. This proves that the cohesive forces were stronger in colder water, which led to a higher surface tension. So why is this so important right now? The applications are everywhere, from medicine to saving our environment. In biomedical diagnostics, the accuracy of blood tests depends on tiny fluid droplets forming and moving constantly. Temperature swings can change the surface tension of blood, leading to inaccurate results and a potential misdiagnosis. By understanding this relationship, scientists can ensure medical labs are precisely controlled, which guarantees reliable and safe medical procedures. Looking ahead, this research is crucial for technologies like drones that clean up oil spills. A warmer spill, for example, would have a lower surface tension, causing the oil to spread more rapidly. A colder spill would do the opposite. Our research allows us to engineer systems that can automatically adjust their suction based on real-time temperature data, ensuring maximum efficiency and a faster, more effective cleanup of our waterways. So this is how temperature affects surface tension. Thank you for watching.